Hi, my name is Jan. I work as an application engineer at MVTec. Today I'd like to show you how you can integrate your MERLIC vision application into your Mqtt infrastructure. When you develop a vision application, you typically reach the point where you like to connect your vision application with other machines. MERLIC offers various ways to communicate with other machines. Out of the box, MERLIC supports different protocols like Mqtt and OPC UA, as well as digital I/O boards, Hilsha CIFX cards, and if you have a very specific interface, you can implement it by yourself with our software development kit for the communicator. The Mqtt protocol is an alternative for the popular OPC UA protocol. It is focused on machine-to-machine communication, and it is often used on modern factory floors. Mqtt stands for Message Queuing Telemetry Transport and is a lightweight, simple, publish-subscribe network protocol. It is an open standard and an ISO recommendation. With MERLIC, you can use Mqtt, OPC UA, or both at the same time. Before we dive into the integration of a MERLIC vision application into a Mqtt network, I like to give those who haven't worked with Mqtt before a short introduction. In the center of every Mqtt network is the Mqtt Broker. Clients can connect to the broker, subscribe to different topics, and publish their own messages on a topic. In our scenario, one client is the MERLIC Vision application. The MERLIC Vision application publishes messages like the status or results of the last execution. Other clients can connect to the topics of the MERLIC application as well and use the messages for further processing or publish other messages on different topics. A handheld device can subscribe to the MERLIC topics. It can visualize the MERLIC results, or it can publish messages to control the MERLIC vision system. Other machines can connect to the Mqtt Broker to react based on the previous MERLIC results, or if you connect your Mqtt Broker to the cloud, you can upload your results directly into the cloud. After this introduction into the concepts of Mqtt, I like to show you how you can use MERLIC together with Mqtt. Therefore, I have prepared a MERLIC vision application that inspects and counts different kinds of food. We are counting and inspecting these small sweets and some crackers. Both are on a backlight panel like this one here. And in the end, we want to control the MERLIC vision application with our tablet. Let me show you the prepared MERLIC vision application. As a first step, I will start our prepared inspectcandies.mv app application. Here on the left side you can see the tool flow of the Inspect Candies application, and I like to show you the front end of the application first. So I click on Open Designer, you can see the front end, and I click on Launch Front End to start the actual application. I can click on this button here, it's the continuous mode, the application is running, and now I can put some candies here. Here is one candy OK detected. If I put a broken candy next to it, we can see that the defect candy is marked as not OK. I can put a cracker next to it. So here we can see like a defect is detected. Or I can put another cracker next to it and a defect is detected as well. To connect this application with an Mqtt network, we have to find the tool that returns the desired parameters, so the counted regions that are OK and not OK. So we are closing or stopping the application first, closing the window here and closing Designer. And then we are looking in our tool flow, which tool returns the desired parameter. From the top to the bottom, we are stepping through our tools. We are zooming in, so it's easier to follow. The first tool is the image source tool. It grabbed the image from the camera. Then we are rotating the image, because the camera is mounted upside down in our setup here. And then we are using the Locate in Backlight tool. It marks all the regions that are detected on the backlight. But of course we don't want to return all the regions, we want to return the defect and accepted regions. So the next tool, Evaluate Regions, evaluates the regions and says if a region is defect or not. Therefore, it checks the circularity, and if the circularity is between a given range, the object is classified as defect or not defect. So here we can see our one candy is okay, and the other three objects are defect. Now how can we implement the application into our MQTT network? We are clicking here on the desired output parameters, number of accepted regions, clicking on this arrow here, selecting int because it's an int data type, so it's a number. We're clicking on add, and we're doing the same for the regions rejected. Clicking on the arrow, clicking on int, and clicking on add. In the next step, we have to save a recipe for this MV app. So we are clicking on MV app parameters and results. Down here we can see the previously selected results. And we can click on Save Recipe. We have to select the name for the recipe file. It's automatically selected in speccandies.mrcp, MERLIC recipe, and we are clicking on Save. Save once again, and we have prepared our first MERLIC recipe. We have to do the same for the second application. So I will open the application now. It's called inspectcrackers.mvapp. I click on the application. Basically, this tool flow of this application is very similar to the previous one. So we're having the same tools, but slightly different parameters. Let me show you the front end first. I will start the front end. And you can see here, the candies and not wanted crackers are marked as defect, so with a green border. And the one cracker at the bottom is not marked because it is okay. I can start the continuous mode once again and stop it. Now I can close the application, close the designer, and we can have a second look in our tool flow. We have the image source tool, rotate image tool, locate in backlight tool, and the evaluate regions tool that we need once again. We are selecting the number of accepted regions, clicking on int as data type, and doing the same for the rejected regions. We are saving the result for this the recipe for this application. So we are clicking on MV app parameters and results and save recipe. And once again, the file name is suggested, so inspectcrackers.mrcp. We are clicking on save and saving the recipe. So basically we are done inside the MERLIC backend. Maybe one more information. If you like to give us feedback regarding the MQTT functionalities or any other MERLIC functionalities, please click on the feedback button on the top right corner. There you will be forwarded to our webpage where you can give us feedback about MERLIC. Now we have prepared our two MERLIC vision applications. In the next step, we can configure the MERLIC runtime environment. To configure the MERLIC runtime environment, we have to first start the MERLIC communicator, which is required for the runtime environment. So we are searching in the search field at the left bottom and typing communicator, MERLIC communicator. and the communicator starts. And then next we are starting the MERLIC PI setup. PI means process integration. We can connect to our local MERLIC system and we can select which recipes we like to use during runtime. So we are clicking on Import Recipe, opening the folder with the previous created recipes. We are selecting Inspect Candies and Inspect Crackers. We are opening both recipes and we are selecting the Inspect Candies application as default. In the next step, we switch to the Communication tab, and here we can select which communication plugin we like to use. We can click on Add Plugin instance, and we can select the OPC UA plugin, the MQTT plugin, and some other plugins. For this tutorial, we are using the MQTT plugin. The plugin is loaded, and as said before, we have to configure a Mqtt Broker. That could be installed on the local host, like expected here, or it can be another Mqtt Broker running on a different machine, or in this tutorial we are using a freely available online Mqtt Broker. This Mqtt Broker has the host name test.mqtt.org. The default port for all Mqtt brokers is 1883. It could be different, but for this broker we are using the default port. Below we can configure additional features of our Mqtt plugin. We can configure the top prefix, here it is called MERLIC. We can configure the message format, if it is a JSON compact or not, and what we like to publish, so the errors, yes or no, recipe data and result data. In this tutorial we are setting all the published data to yes. After we have configured the Mqtt plugin, we can save all the changes and start the plugin. At the background here you can see that the Mqtt plugin starts. Now we can close the process integration setup and we are closing the communicator plugin. To start MERLIC in the runtime environment, we have to first start the MERLIC communicator once again. So we are searching for MERLIC communicator. The communicator starts up. Then we are searching for MERLIC runtime environment, or short MERLIC RTE. So the runtime environment starts up and the front end as well. But we see currently MERLIC front end is stopped, or the MERLIC application is stopped. Why is it like this? In a runtime environment, MERLIC waits for an external trigger that triggers the execution of the application. So currently it's stopped and the application waits for an external trigger. That trigger could be another Mqtt client. To trigger the execution of the MERLIC application, I will use the Mqtt Explorer. Mqtt Explorer is a freely available tool and I use it now to visualize the workflow. I start the Mqtt Explorer. I've pre-configured some settings, so we are connecting to the host test.mqtt.org. It's the same host or Mqtt broker we have connected before. We select the default port 1883 and we are selecting under Advanced the topics we want to subscribe to. And here we have the topic MERLIC/hash. So we are subscribing to all MERLIC topics. We're clicking on Back and then we connect to the Mqtt broker. Here we can see the MERLIC topic. I will open it. We can see that we have received some information about recipes, the status, and if we want to start a single execution, we can publish a message on the topic MERLIC action/JSON. And in this message, we choose the action type that is called Start Single Job. I click Publish, and we can see that one image is grabbed and the image is evaluated. I can remove one of the candies here. I can click Publish once again. I can remove a cracker, publish once again, and the last cracker. And then we can see one candy is detected and it is okay. That was with the Mqtt Explorer. As we have seen now, we could start a single execution via Mqtt, and we can control the MERLIC vision application. And under Recipes, 0 result, we can see the last result. So here we can see the value 1 because one candy is recognized. If we put another candy next to it, click Publish once again, we can see here 2 candies are recognized. Now we have seen how we can control our MERLIC vision application via the Mqtt Explorer. But as said in the beginning, we like to control our MERLIC vision application from a tablet. Therefore, I prepared a small application. It is called IoT On-Off. You can download this application in the iOS App Store. It is freely available, and you can configure it by yourself. Here on this dashboard you can see sliders, buttons and graphs, and they are all connected to the Mqtt Broker. So we are using the MERLIC/action/JSON topic to start a single execution. So we did one single execution or another one, we get the feedback when the application is running, or we can start the continuous execution. Now we have the continuous execution running. We can put some candies here, remove a candy, remove the other one, and we can put a cracker here. Currently we are in the Inspect Candies recipe. So you can see here ID recipe 0. If we click on Inspect Crackers, we can see that we are switching to the different application, and now we have prepared recipe 1. If we click now Single Execution, we can see that one cracker is detected. If you put a second one here, and once again, 2 crackers are detected. But here we have just one machine. But normally we have multiple machines running multiple instances of MERLIC. So if we start our one machine now, in the continuous mode, maybe we have a second one. We can start it now. So the second machine starts up. And we can also execute on this second machine a single job, another single job, or the continuous mode. And now we are stopping the machine once again. I hope you have enjoyed our short introduction into Mqtt together with MERLIC, and that you have learned something new today. See you soon and goodbye.